Hi, so we are going to look at writing fractions as recurring decimals, which is a higher GCSE topic. And we're going to start with a couple of definitions. So a rational number is a number that can be written as a fraction. An irrational number can't be written as a fraction or as a ratio of two numbers. Pi is a good example of an irrational number. It doesn't repeat and it goes on indefinitely. So that is another clue that tells you if a number is irrational. Some more definitions. A terminating decimal has a finite number of digits. Basically, it does what it says on the tin. It terminates, it finishes. For example, 0.25. A recurring decimal has a digit or group of digits that repeat forever, indefinitely. For example, 0.3333 goes on forever. Recurring decimals are rational because we can change them into fractions. So 0.33333 recurring can also be written as a third. And the way we denote recurring numbers, recurring decimals, is using the dot above the number. And it means, so for 0.3 with a dot over it, it's the 3 that repeats. For 0.16 with just a dot over the 6, it's just the 6 that repeats. When we have dots over two numbers, it means that the section between them repeats, or in this case, the 1 and the 8 repeat indefinitely. And in the last one, it's the section between the two numbers with dots on that repeats, so 752, 752, etc. And the way to tell whether a fraction will convert to a terminating decimal or not is to look at its denominator. If the denominator only has prime factors, so things that multiply to make it, of 2 or 5, it will convert to a terminating decimal. So a half, the denominator here is 2, so that will convert to a terminating decimal. And a fifth, again, denominator 5, so we can write that as 0.2, which is a terminating decimal. 1 over 10, so 10 can be written as 2 times 5. Its prime factors are 2 and 5, so that can be written as a terminating decimal, which we can see is 0.1. 1 over 4, so here the denominator 4 is 2 squared, so again, terminating. And similar, 3/4, the denominator is the same, and we know both of those. A quarter is 0.25 and 3/4 is 0.75. So the rule is that if the prime factors of the denominator are only 2 or 5, they will convert to terminating decimals. They won't be recurring. So all other fractions convert to recurring decimals. So 3 has not got prime factors of 2 or 5, so it's a recurring decimal, 0.3 recurring. 2/3, same denominator, 0.6 recurring. And a 6th, the prime factors of 6 would be 2 and 3. So because of the 3 there, it means that this is going to be a recurring decimal. And 1/11th, also a recurring decimal. So you might get asked to write a recurring decimal as a fraction, and we're going to look at a few examples of that. So if you are asked to write 0.3 recurring as a fraction, you probably know already that that is a third, but we're going to show it. So we give a letter to the recurring decimal, can be any letter, I've chosen Y here, and we write it like this. And then I've written it out in full to make it a bit clearer what we're doing. So what we're going to do is we're going to multiply the Y by 10. And the reason is what we're looking for is the same repeating chunk after the decimal point in two different numbers, so that when we subtract them, we get rid of all the recurring bits after the decimal point. So in this case, because Y is 0.3 recurring and 10Y is 3.3 recurring, if we do 10Y subtract Y, we actually get rid of all the recurring 3's after the decimal points, and we end up with 3, which we can now change, collect up our like terms. So 9y is equal to 3. And if 9y is equal to 3, y is equal to 3 divided by 9, which we can also write as a third. So slightly more complicated. If y is equal to 0.81, where both the 8 and the 1 are recurring, again what we're looking to do is get another number with exactly the same bit, exactly the same chunk of recurring numbers after the decimal point. So in this case, we're going to multiply it by 100, because multiplying it by 100 means that we've got 81 in front of the decimal point, and again we've got 81, 81, 81 after the decimal point. So when we subtract, 100y minus y just leaves us with 81, because the 0.818181 take away 0.818181 is nothing. We've gotten rid of it. So collecting up our like terms, we've got 99y is 81. And rearranging, that means y is 81 over 99, which we can simplify down to 9 over 11. So another example, this is a little bit different because the number after the decimal point is not recurring, but the one after that is. So what we need to do here is first of all multiply the y by 10. So we've just got the recurring bit after the decimal point. And now we're going to use this as our starting point, and we're going to multiply this by 10. So we've got another number with just the recurring bit after the decimal point. So now we can do a subtraction. 100y minus 10y will give us 34.4444 minus 3.4444, and those 4's will cancel out. So we've got 34 minus 3, which is 31. So we can collect up our like terms again, and we end up with 90y is 31, or rearranged, y is 31 over 90. So that is our decimal written as a fraction. So this one, just getting a little bit more complicated. Similar thing to start with. We've got a non-recurring number after the decimal point, but that's okay. We know what to do. So we're going to, this time I've called it x, to change it up a little bit. We are going to first of all multiply by 10. So we've just got the recurring bit after the decimal point. And then we are going to multiply this number by 100. So again, we get a chunk of the recurring bit after the decimal point. So multiplying 10 by 100 actually gives us 1000x. And multiplying the right-hand side by 100 gives us 512.121212. So now we can subtract 10x from 1000x, which will give us 512.121212. Subtract 5.121212, and those recurring bits again cancel out. So we are left with 990x is 507, which we can rearrange to x equals 507 over 990, and this simplifies to 169 over 330.